All right, 681. We're going to talk about two things today. One of them is the concept of average value, and the other thing is total area. So let's just go ahead and jump right into the average value formula. So again, f is something that we can take the integral of on a closed interval from a to b, and the average value is this. So if we just ignore the 1 over b minus a, the integral from a to b of some function is just the total area. Okay, that's the overall area. I shouldn't say total area. That's the area from a to b of that function. Okay, so that's your area. When we take the average value and we're dividing by 1 over b minus a, we're basically finding like the average area of each of those rectangles from that starting point a to b. So but basically, it's a formula that we need to know. I know I talked about it in a previous set of notes when I went over some problems, but there's your formula. So we're just going to go ahead and do an example, or two examples really. So find the average value of this function on the interval from 1 to 4. So when we set this up, we're going to have the interval 1 over 4 minus 1. Not necessary to write that at all, just write 1/3. Going from 1 to 4 of this function, 3x squared minus 2x dx. So we're going to have the 1/3 out front. Take your integral. So the integral, hopefully we can do these kind of quickly shorthanded here now that we've done a few of them. So 3x squared, the integral of that would be x cubed, minus the integral of 2x would just be x squared. And we're going to evaluate this from 1 to 4. So again, I'm going to leave my 1/3 out front and plug in my numbers. So 4 cubed gives me 64, right? 4 times 4 is 16, times 4 is 64. Minus 4 squared is 16. All right, so that's my first part. Let me put a bracket around this. That's the first part, plugging 4 in. Minus, let's plug 1 in. So 1 is 1 minus 1, which is actually going to give me 0. So I don't need to worry about this. So then we do on our calculator, we're just going to go ahead and do 64 minus 16. So I got, what's going on here? 1/3 times 48. Okay, and then 48 divided by 3, or 1/3 times 48, whatever, however you look at that, we're going to end up with 16. Okay, so we're ending up with the average value of 16 on that interval from 1 to 4. All right, so go ahead, pause the video, write this down, try the problem on your own and see how you do with it, and then come back and check your answer. All right, so let's go ahead and go through this. So I got 1 over pi over 4 minus 0 is just pi over 4. Integral from 0 up to pi over 4 of secant squared x dx. All right, so we need to figure out, well, again, this is something that you just need to memorize, the integral of secant squared. Okay, that's something you just need to memorize. See, the integral of secant squared is just tangent. So 1 over pi over 4 gives me 4 over pi. And then I have the integral of secant squared is tangent x. Again, for these we don't need any plus c because we have the interval on the integral. So these are definite integrals, so we don't need a plus c. We're going to evaluate this from 0 up to pi over 4. So I have 4 over pi. That's not a pi. Try again. 4 over pi. There we go. Tangent of pi over 4 is 1, minus tangent of 0 is 0. So I'm left with 4 over pi times 1, which just leaves me with 4 over, oh my word, I'm doing it again. Let's try that again. 4 over pi times 1 leaves me with 4 over pi. That's better. Final answer. Okay, that's an exact answer. I mean, you could approximate that using your calculator or whatever, but that's good right there. All right, now, what I want to look at next is leading into this concept of total area. So first of all, let's look at this. Ignore the graph for now. Let's look at this. If we take the integral from 0 to 2 of 2x minus 1, we try to do the absolute value of 2x minus 1. Maybe you will and maybe you won't realize that we have a problem here because, first of all, we haven't really talked about doing absolute value yet. But also, let's say if we do just say that this integral from 0 to 2 of absolute value of 2x minus 1 dx. Let's say we do call this x squared minus x, and we do the integral that way, evaluate it from 2 to 0. So what happens when we plug that in there? We end up with 2 squared, which is 4, minus 2, and we end up with the area of 2. Now, this is wrong. How do we know it's wrong? Well, let's look at our graph over here now. So all I'm looking at is the area of two triangles, right? I got this big triangle over here, which is really not that big of a triangle, and then I got this little triangle, right? So I have two triangles. These two triangles, this is terrible. So I got these two triangles right here. Actually, let me do them in different colors so I can talk about them. I guess I could just say big triangle and little triangle, but I'm already committed to changing the color, so I'm not going to back up now. Here we go. So let's say for the blue triangle, if I find this area, I have 1/2 the base, which is 1/2, times the height, which is 1, plus my red triangle, which has a formula 1/2 the base. Okay, the base is what? 1.5, or 3/2, times the height, which is all the way up here, gives me 3. So what happens when I do this? Well, I end up with 1/4 plus 9/4, which gives me 10/4, which is 5/2. Okay? Pretty close to 2. It's only off by 1/2, but it's still not the same. So why? Why is that not okay? Why do we not get the same answer when we did this? 5/2 is the correct answer because we found it by using geometric formulas. So what happened here? What's the problem? And hopefully you can recognize that the problem with this is right here. Okay? And the problem there is that that's a cusp, which means the derivative didn't exist, and if the derivative doesn't exist, the antiderivative doesn't exist there. So we need to be able to look at this and understand that there's a problem here. Okay, so the way that we handle that problem is with this concept called total area. All right, now the total area, basically it does two things. One, it does what I just said, and it forces us to look at a function around the absolute value and take those those sharp turns, and split it apart. But the other thing that it does is total area forces every portion of the graph to be positive. So what I mean is, like, we could have, let's say we have some function that looks, like this or whatever, and the total area is going to take these negative areas and force them to be positive areas. Okay, so that's what total area is talking about. Okay, so doing the absolute value, that's what happens there. It kind of forces the whole graph to be above the x-axis, as all of our answers will end up being positive. And then, that's how we end up with our total area, which is all positive. Now, what we need to do is we need to find all of these points, okay? We need to find all of those points, and what we're going to do is we're going to split up our integral around that point using this formula, or this property that we had before, that if we have the integral from a to b of some function f of x dx, remember we can do a to c of f of x dx plus the integral of c to b of f of x dx. Okay, so that's what we're looking at. And then what we'll do is we'll take any negative areas that we get and we'll make them positive because we have these absolute values here. Okay, so that's what this whole concept is talking about. I should have given you time to pause and write it down first, but I explained it first, and now you can write it down. So if I come back to this problem right here, we can rewrite this. So let me clear out the writing here, and we can rewrite this because we know that 1/2 is the problem point. Well, how do we know 1/2 is the problem point? Well, if you remember back to Algebra 2, that was the vertex of this. So the vertex was 1/2, 0. Okay, you did that in Algebra 2. I know it was a few years ago, but that's how we do it. So what we can do here is split this up, and we can say 0 to 1/2 of this function, which I'm just going to abbreviate f of x dx just for the sake of time, plus, and then we're going to go 1/2 to 2 f of x dx. Now, for this problem specifically, we had to do a little bit more than this because what we have to do, not only splitting it up, but we would also have to find out what is the equation of this line right here, which the equation of that line would end up being y equals negative 2x plus 1, and the equation of this line over here would be y equals 2x minus 1. Okay, so that would be, let's call this g of x, and we'll call this f of x. Coming back in here and cleaning this up a little bit, actually making it correct, it would look like that. Okay, so sometimes you'll have absolute value problems like that where there's a cusp you have to work around, and sometimes you'll have problems like this example I have here, where we have negative area to work around. So let's first of all, let's see if we can graph what this looks like. So go ahead, we're going from 0 to 2. What I want you to do is just see if you can sketch this out, what this graph looks like. All right, so hopefully you did that, and let's see what we got. So this graph has a vertex at 1. If I plug in 0, I get 1. So it's got a vertex up here at 1. At 1, if I plug 1 in there, I get 1, 0. So it's actually going to curve down like this and hit 1, 0. And then after that, it's going to continue down to where if I plug 2 in, I'm actually ending up getting a negative 3. Right? So down here at 2, I'm going to have a negative 3. All right, so we'll call that right there is going to be the end. So that's my point right there that satisfies that. So what you need to be able to do is recognize either where a cusp occurs, that sharp turn, or where your function is equal to 0. And we'll actually just split it up around that. So that's what we're going to do here. 0, we know this is 0 at 1. So from 0 to 1 of 1 minus x squared dx. Now this is not like absolute values where we have to rewrite the two equations because this is still the same curve, it's still the same function. We don't need to split that up. So it's still going to be the same function here. So I'm going to do plus, excuse me, the integral from 1 to 2, 1 minus x squared dx. Now we know that this area from 1 to 2 will be negative. This right here is going to be a negative area. So when we do that, we have to remember that we're going to take the absolute value of that number, and it's important you have your absolute values on the outside there. So our final answer will be positive without anything being subtracted away. The way the formula is written up there, the absolute values are in here, because really what we're doing is when this graph comes down to this point, what we're doing is just kind of like moving it up. Okay, so that's what we're doing there, but the other way of doing it is like this. Okay, it's the same thing, it really doesn't matter. So let's do our antiderivative. So 1, the integral of 1 is x. The integral of x squared is going to be x cubed over 3. And we will evaluate that from 0 to 1. Okay, evaluate that from 0 to 1. Now, since I know this is a negative area, what I'm going to do is I'm going to subtract. You could also just do that. I know I'm throwing in a lot of things, I'm mixing it up here, but I'm just showing you these are all algebraically correct, and I want to make sure you see every option here. So we're going to have the same antiderivative, okay, the same integral here over 3. But now this one is going to be evaluated from 1 to 2. Okay? Let me kind of separate this stuff over here so we know it's not part of it. All right, so let's go through and do this. Now basically all we need to do is just plug our numbers in here, all right? So 1 goes in here, I'm going to get 1 minus, plug 1 in there, I get 1/3. There's my first part. What happens when you plug 0 in? You get 0 minus 0, which is 0, so I'm not going to write that. Okay, minus, let me put my bracket here, plug in 2, I get 2 minus, 2 cubed is 8, so I have 8 over 3. Minus, what happens when I plug 1 in? I get 1 minus 1/3. Now, don't try to skip steps here because it's very easy to make little mistakes. So let's just go through and do this one bit at a time. 1 minus 1/3 is 2/3. Minus, let's do this stuff in here. 2 minus 8/3. Well, 2 is 6/3. Minus 8/3 is negative 2/3. Minus, and then 1 minus 1/3 is again 2/3. So I get a lot of 2/3 here. So 2/3 minus negative 4/3. Oops. Switched it over to a bracket. There we go. Double negative. So I'm going to end up with 2/3 plus 4/3 is 6/3, which is 2. So there is my final answer, 2. Okay? So here you go. Here's some problems to try. Let me know if you have any questions on this. I know I may have gone through that last problem a little too quickly or something. So if there's something in there that you're not sure about, if you're a little confused on it, please let me know. Send me an email, and we'll try and get you squared away and figure out what the problem is. And I'll help you to get moving along with some of these problems. So if you have any questions, let me know.